There's a theory, strange, elegant, and deeply unsettling, that suggests everything you've ever seen, touched, loved, or feared might be a projection. Not an illusion, not fake, but a hologram, a three-dimensional reality encoded on a two-dimensional surface. It's called the holographic principle, and it begins, as so many great mysteries do, with black holes. Let's return to the edge of a black hole, the event horizon. We know that anything crossing this invisible boundary is gone, irretrievably lost to the outside universe. Or so we thought. But in the 1970s, Stephen Hawking proposed that black holes emit radiation, now known as Hawking radiation, and slowly evaporate over time. If they eventually disappear, what happens to the information they swallowed? In physics, information is sacred. It can't simply vanish. Even if an object is destroyed, the information about its original state must somehow remain. But black holes seem to erase it permanently. This contradiction became one of the most profound puzzles in physics, the black hole information paradox. To solve it, physicists began to wonder, what if the information isn't lost inside the black hole, but stored on its surface? That's where the holographic principle comes in. It suggests that everything happening inside a black hole, all the matter, energy, time, and information, is encoded on the event horizon like a cosmic film strip. The three-dimensional experience inside is just a projection of that two-dimensional information. But if that's true for black holes, could it be true for the entire universe? Could our entire 3D reality, from stars and galaxies to forests and cities to your thoughts and dreams, be encoded on a vast two-dimensional surface at the boundary of the cosmos? This idea isn't science fiction. It's a serious theory, born from the crossroads of quantum mechanics and general relativity. In 1997, physicist Juan Maldacena proposed a version of this principle in string theory, showing that a certain kind of universe with gravity could be mathematically equivalent to a universe without gravity on its boundary. In other words, a 3D universe could emerge from a 2D one. Think about that. You are living in 3 dimensions. You move forward and back, up and down, left and right. But beneath that experience, underneath the math, everything might be described by a flat sheet of information. Just as a hologram on a credit card contains a 3D image encoded in 2D light patterns, so too might our universe arise from a flat horizon we can't even perceive. It's not just theory, there are hints. When scientists study black holes, the amount of information they can hold doesn't depend on their volume. It depends on their surface area. That's not what we'd expect. In most systems, more space means more information. But not here. Black holes flip that logic. They store information on the edge, not inside. And if black holes obey this rule, maybe the universe does too. Some physicists believe this principle could solve the tension between quantum mechanics, the physics of the very small, and general relativity, the physics of the very large. Because at their core, both theories work beautifully, but they don't agree. They offer different pictures of reality. The holographic principle might be the bridge between them. It's speculative, yes, it's unproven, but it opens doors. What we call space may be emergent, a phenomenon that arises from more fundamental ingredients, like temperature emerges from molecular motion. Space may not be basic, it may be built, and if space is emergent, maybe time is too. Maybe time, memory, even causality, the idea that one thing leads to another, are part of a deeper structure we've only just glimpsed. So what does it mean? If our universe is a hologram, does it make our lives less real, less meaningful? Not at all. Think of a rainbow. It's made of light, of refraction and angles. It's not solid, but no one would say it isn't beautiful. Reality in any form is still real. Whether it's built from particles or pixels or projections, whether we're in a fundamental universe or a holographic one, the experiences we have, love, wonder, fear, curiosity, are genuine. And perhaps the holographic principle doesn't make us smaller. Perhaps it makes us part of something grander, something more intricate and mysterious than we've ever imagined. Because if reality is written on the edge of the universe, then we are written on the edge of time. And every thought you've ever had, every story told, every dream dreamed, it's part of that script, etched into the fabric of existence, preserved, projected, alive. So tonight, when you close your eyes, imagine the stars around you as characters in a story written across the sky. Imagine yourself as light dancing between dimensions, a ripple of something deeper, a shadow of something greater, not less real, but more connected, more eternal, more cosmic than ever before.